Okay, great. So, okay, just to like say a little bit what this meeting is going to be about. It's playtime with RSM, and I'm excited about this. And until now, it has been awesome. Everything I have done with RSM has been quite awesome. So I'm excited to share this with you guys. So what do you want to do? Like, I propose to build a small application, but open to anything, and what that application should be. We could also review code. What are you excited about?
And also, first of all, Holoamix.
Yeah,
So,
Holomix. Sorry. Yeah.
Amix is the name of our new group. Actually, the name is Amix. So, thank you everybody, and also you especially, Guillaume. And my suggestion would be, should we start with a little bit difference between the DHT behavior or a different meaning of a reality? What is the differences here? And if anybody also on the same page, we can go. Do you think it is value? Should we start a little bit fundamental first, or just go coding, zoom changes?
Right. Okay. Okay. If I knew that I had to present these, I would have, because okay. So RSM is going to be released on Tuesday, and I want to do a differences guide, mini guide, but I don't have it yet. I have it more or less on my mind, but anyway, I can.
Yeah, just
yeah,
informally, like whatever.
yeah, right. Yeah, right. Okay. Is that okay with everyone? Yeah, I guess so. Yeah, this is one. Okay. Okay, so good news is that not much has changed from the conceptual standpoint, but there are some caveats and some things that we'll need to keep in mind. So first, I can do like 3-4 points that are important, and then I can go in detail into each one. So points that are important. Headers are more important now. Like, if you do a get, that get gets you a header and an entry. That's header first. Second thing, updates and deletes all reference headers, not entries. You cannot have update loops because you cannot have header loops. Okay. More things. Let's see.
Sorry, Guillaume. The second thing you just said, can you just repeat it again? Sorry.
Yeah. Updates and deletes. So when you say update entry or delete entry, reference headers. They do not reference entries. In the last version, they referenced entries. So you say, I delete this entry with this hash. But now you say, I delete this header with this hash.
So it just points directly to where the latest version is. Is that right?
In the case of the update, yeah.
Yeah.
Okay.
How does it?
Yeah.
Sorry. How does it prevent the update loops?
Yeah. Okay. Let's focus on this now, because there are some questions. So, okay. So what you had in the previous version is that I'm updating the entry with this hash. So if I'm updating the entry A to entry B, that's all fine because different hashes, different entries, and so on. But if I do update A, update B, update A again, because you can update to the same old content of a tweet or whatever, then that would cause an update loop. And if you try to do a get with that, it goes A, B, A, B, A, B, because it tries to like get the latest version, but that's the update loop. In RSM, that's not possible. Why? Because I'm updating the entry with this, actually, I'm updating the header, this header with this hash to this new header. So actually, if you think about it, there cannot be a loop in that because headers are chained together and are timestamped, so you cannot get the same hash with not previous, the other one, the future header. Like you cannot go ABA because that third header cannot be the same as the first one because it's after. So you cannot update to the same header as the first one, basically.
Because the timestamp is a new factor in there that would make it more unique. Is that why?
Not only that, but you cannot get the same header in two chains ever because the second or third entry, I cannot remember now, is the agent ID. The agent ID is the public key. The public key is supposedly only unique. You can only have it. And because the headers are chained, there is no way for me and you to have the same headers if we are coming from different agent IDs.
Got you.
Yeah. Okay.
Thank you.
Yeah, sure.
That sounds great.
Yeah.
Do you have extra thing here? I would like to add something.
I have more on updates
go.
deletes, but okay.
Go, please.
Okay, so if you think about it, now things get a little tricky. And why is that? Because, for example, let's imagine that me and Hedayat have tweeted the same tweet. If I'm deleting Hedayat's header, what happens with mine? You know, mine hasn't been deleted. So is the entry still alive or not? Because mine, nobody has a problem with, and Hedayat has been deleted, right? So the way that this works is kind of like reference counts. So if you have deleted all the headers that are besides an entry, that entry becomes deleted. Otherwise, that entry is alive, even if only one header is alive. You know what I mean?
Yeah, sure. It is like a counter signature
right.
in the Rust. In the Rust, actually.
That's exactly right. Yeah.
So,
Yeah, Sid.
Yes.
Sorry, Sid. I don't know.
Yeah.
You look like you're still thinking.
again, I think if I explain something here, it makes your life a little bit easy to explain more.
Yeah,
Can I share
please
my
explain.
screen?
I'm still thinking through it.
Sure.
Yeah, look, there is a changes here that all of us waiting for it for a while. It happened, okay? What's happening? Guys, there are two topics in the Holochain we really needed, but we haven't had it. And in RSM, you can easily see, and that's why we love it actually. What is the topic? One topic is the fingerprint of action. They are header, and that's why Guillaume mentioned that they are more important. Just look, any event, any activity we are doing on data entry, they are gonna be header. It is the chain of activities, events, the things happening. Right now, it is split it up with the data. It means we have a data here, name entry or hash or something like that, okay? It means if two guys totally create a good morning, Guillaume create a good morning Twitter, I create another good morning. We are not duplicating the content. We are creating a two header. Got the point? Guillaume, correct me if I'm right, or do you want to add, please?
No, you're right. And in RSM, that's the same.
Yes, exactly. And look, what does it mean? If Guillaume create this entry first, good morning to anybody Twitter, Hedayat is coming and create a good morning. Both of us, we have one unique content, and we have a two guys as a headers, create headers referring to one good morning, one good morning, good morning. So, and what happened if Guillaume want to delete the good morning? So if it would be one, if the owner would be one, when we delete it, so we can assume good morning is deleted entry. But right now, if we have Hedayat and Guillaume, and both of us has a good morning entry, if Guillaume say, hey, delete my good morning, but this entry is still alive because it's still another one referencing this entry. Is it clear?
Yeah.
That's it. The topic of a header exactly split it up cleanly. The data can be anything. Header can be event. It is cleanly and clearly inside the RSM. That's it. Sorry, Guillaume, that I interrupted you. I just want to.
No, thanks. It was very
Awesome.
helpful.
Awesome. Yeah. Okay, that's for deletes. What happens with updates? So just a step back, RSM's philosophy is much more to give you the tools you need to figure out what's the best way to implement the logic of your application, and not so much to code things in core that are assumed are good for everyone. For example, gets and updates do not follow the update chain. When you do a get with a hash, it does not still, at least, follow the updated entries for that, because maybe you don't wanna. And it's costly to follow the update chain, right? So maybe you want that hash and that's it. So that's more or less the general philosophy. You can think of it as we don't want to assume what the developer is wanting to do. We just give you the tools, and that's more work for us because we need to figure out some logic that maybe was buried inside previous version of Holochain, for example. So in that note, how does updating work, at least for now? You can update an entry many times. The same entry. Because if I update my header, but another header is updated to something else, like Holochain natively doesn't have a way to know which update is the correct one, so it just holds both. So this header has been updated to that entry, that's all right. This header has been updated to that entry, that's all right. And when you do the get, you need to figure out the best way to navigate this. Okay, so let's assume, because here is a better a good example, I think. So Sid does a tweet or what? No, a Google Doc. That's a better example. Sid does a Google Doc, and I receive it, and then we do a partition. So Sid is disconnected from my partition, and we both update, right? So when we merge, both updates should be there. But then when I do the get, I'm like, oh, okay, this document has been updated to two different paths. Okay, let me figure out, okay, maybe the answer for Google Docs is to show the two different documents. Maybe the answer is to follow the larger timestamp. It depends on the application, right? So that's one thing. Another thing about updates is that in the future, things like redirects and also update chain propagation might be implemented, but they are not right now. So redirects in the sense of maybe the get call will follow the update chain if you provide a callback to say which one of the updates is the redirect. But I think we shouldn't focus too much on that. That's future, but more or less to see where we are at. Like RSM is not finished by any means. Okay, I think that's it for.
So
CRUD.
how do you mean callback? Like how?
Yeah.
Like
so
we have to introduce the callback. What does that mean?
Okay, imagine in that Google Doc example. Holochain doesn't know which update is the correct one. So if Holochain is supposed to follow the update chain underneath, we need to provide a callback to say which one of the updates is the valid one,
or the one we want to get.
The redirect, yeah.
Yeah.
The redirect, like the concept of redirect is from this entry, there is multiple updates, but there is one that is the one we want to follow when to do a get. So, okay, the callback will be, I give you all these updates that have been happening, and you have to tell me which one I should follow. And if not, you can implement this by yourself, like get the first one and then get the second one and then get the third one. But this is slow. So what they want to implement also is, okay, if I update the latest version of a redirect, let's propagate that back to the beginning to be able to get from the original entry, and that original entry has the information about the latest one. So with one hop, I can just jump. So you know about all the anchor pattern data first, or that if that's implemented, that's gone. Like you don't need that, because if you update normally, it works performant. Basically, with one hop, you get from the first one to the end one. So that has implications in designing things. Okay, how am I doing until now? Do you want me to keep going other features or other things?
No, this was good. I think we're just trying to process the implications of this.
Right. Yeah, it's difficult.
Yeah, I think starting with some code would give more context for what you just explained.
Right. The thing is that right now with the code, you don't see much of that. I don't think I have code until now updating update entry and getting and so on, just because I haven't. It shouldn't be that hard, so if you want, we can do that. Okay, I'm trying to think, is there anything else we should talk about specifically? Like from the conceptual standpoint? I don't think so. Maybe the last thing is that the concept, there are a couple concepts that have been renamed. So the concept of instance now is called cell. So if you think about it, like you have the DNA of the application, and each instance of a DNA embodied is a cell. So I have my cell of this DNA, and Hedayat has its own cell of the same DNA, but we have two different cells. So the metaphor holds. And then an application is what we know about of a hub bundle. So various DNAs coming together, that's an application.
And so how is that specified? Like, is there somewhere where we can now say this is a hap bundle or all the DNA? Yeah.
Okay,
is there something special?
I should talk about that too. So I think it's better if I show some code. Let me grab it. Okay. Okay, can you see my screen?
Yep.
Yes.
Okay. Folder, this folder, please. Okay, yeah, I mean this folder. Okay, so specifically to answer your questions here. Okay, you know how we had HC Web Client in the past to connect with the Holochain Conductor and so on. So now that's gone. Now that's called Holochain Conductor API. Okay, it's the same concept. It does more or less the same things, but it's better and it's clearer, and yeah, things work pretty well. So you have the admin WebSocket, and then to answer your question, you do things like install app. And then inside the app, you pass a list of DNAs.
So where is this code being executed and at which moment?
Right. So I'm thinking about this. This you wouldn't have normally in a UI application. And why is that? Because the install app is already been done. What you are doing when you are cloning a DNA, as we know, cloning a DNA is just adding a new one of these, not installing a whole separate app. And let me see, I don't think there is a callback for that, at least yet. Yeah, there is no callback, call for that yet, but maybe in the future there will be. I think this is something like the admin UI for Holochain will be calling, like when you do in Holoscape that you do install application, then this is what's going to be called, basically.
I see. So instead of defining this as a configuration file, when we were using, I don't remember, YAML or 2ML, something like that, you write list of your DNAs in JavaScript code that is then executed by the conductor when your backend is being installed.
Yeah,
correct?
Exactly. That's exactly
Okay.
right. And so that's the other thing I wanted to talk about here, which is this is what the conductor config looks like now. So
Not much.
not much. The conductor config is not a place in which you declare the instances or the DNAs you will be running. No more. And I think that's very good. Because what would actually happen in the previous version of Holochain is that the conductor config was like the living file that was changed every time that a new DNA was installed. So there was nothing more than that to tell the conductor that a new instance is running and is there. So I think that gives a lot of issues along the way. And right now the instances and what instances are running or not are stored in a dynamic database, because these things are dynamic, right? So you shouldn't be configuring those with a config file. So right now the config file is just to define, here I'm defining the driver ports and where my databases are located. And that's that. I haven't gone too deep on the config file because actually there is not much there as of now that app developers want or need or use at every moment. So just the minimum to get me by. This is what I've done.
So that path, the environment path, the databases that has other configuration in there.
Right. So I can show you what's in there very briefly, but it will be mostly boring. So there is a conductor database, but you see this is MDB. .mdb. So this is actually like in other databases you have other kinds of files. Here Holochain is using LNDB, and the data that LNDB stores is like well, it's more or less readable, but it's basically obfuscated, right? So it's a database file that with all the properties that a database file has, right? So it's only it's not to be human readable, and it's not for you to go and meddle with. It's a database file that when Holochain puts up, it reads that database and it does things.
Okay.
How do you then know what kinds of DNAs are installed on your conductor? Can you query this database?
Right. So right now, what you have is this, and what I know.
I see.
All on the conductor, not just the HAP bundle. Every DNA on the conductor, as in not just within that HAP bundle.
Sorry, I'm not getting quite the question.
So when you run this list DNAs, you get list of everything that is installed on the conductor, regardless of how many apps there are.
I think
you
so.
don't get Okay.
Yeah, I think so. Let me see what this
That is really cool.
RI string. I think so. Although I wouldn't be, I would be a little careful about this because it may be that we as app developers don't have access to the admin WebSocket. And why is that? Because then we could mess around with other DNAs that are not our own. So I would be a little careful about that just for now and see how things unfold in the future.
Yeah, and it's also just privacy concerns, right?
Yeah, that's right.
But it would be very useful to have that information. Yeah.
Yeah. So let's see. This is one of the areas that is not like, it's a couple layers up of what the focus is right now. So the focus is networking and getting the core to work. So, and the core is working. It's just adding a couple of fundamental pieces to really bring everything together. So in contrast, you have this app WebSocket that you can connect. So every application that you install this way can be attached to a port, and then you connect to the port like this, and then you can do things like call Zoom, app info, things like that. So basically call Zoom, and then app info sends you valuable information about the Zooms, and yeah, sorry. So you have the app ID and the cell data. The cell data looks like not that many, not that much information. So basically the cell ID. The cell ID is the identifier of the cell. So the instance running in RSM.
So just to summarize,
Yes.
this JavaScript library that you are showing right now would be used to, first, for developer to define code to be executed when installing the application. And second, also to work with the zones, since you have call zone functions. I'm a little bit confused about that.
Yeah, so there is the admin WebSocket and the app WebSocket. These are in the same library, but basically two different classes. And what you will be dealing with in your everyday applications is the app WebSocket. So a WebSocket connect to whatever, and then a WebSocket calls Zoom. That's basically what you will be doing.
I see. Okay, thank you.
And then the admin is for things like cloning DNAs, and we'll see how it's done in the future. Okay, so should I jump into an application and like, yeah, okay. I'm going to open the one I sent over. Yeah.
Real quick, you mentioned like there's a few changes in some functions, like messaging is changed to RPC, and any other changes like that?
Like
Yeah.
there are some changes in that. Instead of get entry, you have get, instead of, like, you have semantic changes basically. A little bit syntax, like the syntax is changed a lot. Okay, let's see. I think it's easier for me to just show you this.
Yeah.
So okay, so this is a very small function which is create meeting room. It receives a name, a description. A meeting room, it just name, description, and owner. And then you have, for example, commit entry. So if you see, commit entry and all other HTTP calls are now macros, they are not functions, which has some advantages and some disadvantages. The disadvantage is that I don't have now the intelligence of, okay, commit entry, and what do I do that? What do I give this now? Like I don't have any information about that. I have to actually go inside and say, and figure out, okay, this is the argument that's needed, and then this is what it's going to be put into, and okay, there's a little more difficulty in that. The advantage is that you can do things like link entries, and then there is an optional argument, which is the link tag. And if you don't put the link tag, it's like there is no link tag. So things like that. Or other changes like commit entry. This commit entry now returns the header hash, not the entry hash. So you have to be doing this all the time, basically. So entry hash meeting room, that gives you the hash, and you link, and you return the hash. But you can see that the basic gist of it remains the same, in the sense that create meeting room, okay, define the struct, entry hash, commit entry, link entries, return hash, that's it. Get all meeting rooms, okay, let's get the anchor, get links, and get each, map it over and get each one of the hashes, right? So things that, okay, pause. Any questions on this first?
Yes. So I see that you are calculating entry hash on line 32, and then you are committing the entry. So on which moment is your entry actually committed? On line 34? Yeah. And then on 32, you're just pre-calculating what would be the hash of the stored entry.
Yeah, exactly. This you would do this with an anchor also, for example, just to do a get.
Okay, I see.
And right now, can we also talk a little bit about transaction, the scope of the commit?
Yeah, that's a good one. Thank you. So that's a big other change and benefit that we all get just free, which is everything is transactional now. Not only everything is transactional, but Holochain has spent a whole amount of time designing things so that if you shut down the conductor at any point in time, the next time you open it up, everything is still fine. Which, if you think about it a little bit, was not the case in the previous version. And why is that? Because imagine the conductor gets shut down just when I'm gossiping with another peer. So if that connection is not stored somewhere in the disk or somewhere, that connection is basically lost. And if I were sending some warrant, then the warrant doesn't get sent. Things like that, right? So Nastasia, you are a backend engineer and you are doing this basically all the time with backend services. So what we have right now is first, everything is stored on disk, and whenever you put up the conductor, it resumes all the work that was pending. Even if the work was interrupted, it begins again the work. But more importantly for developers is that all zone calls are committed in a transactional way, which means that Holochain executes a zone call and either everything succeeds or everything fails. Like, imagine, for example, let's say that I commit this entry, and then in parallel, another function is, I don't know, committing another entry or like whatever it is that it will be doing. The two things can get into race conditions first. They can get into, okay, I have a header here and a new header here that are not like, I've actually forked my chain and I didn't want to do that. So things like that. And in this way, what you get is that, okay, Holochain what does is run all of this first, store what wants to get to be committed. Okay, so I'm just going through this. Okay, nothing committed, nothing committed. Okay, we want to commit an entry. with a header and so on. That's okay. Let me store that. Oh, we want to link an entry, this entry with this entry. That's also a header. Okay, so we have two things to commit. Okay, we are done, perfect. After everything is run, then validation on everything is run. And then if everything succeeds, both things are committed to the sort chain. What if in parallel there was another call that was doing the same thing and it conflicts, right? For example, here I'm getting the latest header and now it's not consistent with the state. It fails. So commits only succeed if no other call was committing in parallel and finished before you, basically. And this has a lot of benefits for us app developers, because you can be sure, like, for example, let's say that you do a commit entry and that validation pass, and you do a link entry and that validation fails. So in the past version, the commit will be still valid and will still get through. But in this version, it won't, because this link here is rejected, because it treats everything like a block.
Isn't
So-
that problematic also?
In what way?
Why? I mean, all my commit entries are getting rejected because of one mistake or one rejection.
Mm-hmm. So, but now we have the freedom to decide how do we want to split the zone functions. So if you want two things independent to each other to succeed, maybe independent to each other,
Correct.
maybe you do two calls instead of one.
So now our zone functions are atomic, basically.
Yeah, exactly.
Awesome. And the transaction log is kept for everything that hasn't been yet performed. And only after things are written into transaction log and verified, they would be executed in box.
Yeah.
Awesome.
Yeah. Not only that, but here you get a customized cache that you don't get in other function calls. So imagine I'm committing this meeting room and now I want to get it. Okay, now I have a customized cache for this zone call that allows me to get it directly because I want to commit it, right? So it's like a workspace for just this zone call. But here I don't have it because I didn't do anything with it. Right? So Nastasia, you're
Yeah, I got confused.
Okay.
What is something that you are doing in one function and not doing in the other? And how does it translate into the cache, and what is the cache? How do you work with it?
Okay, sorry. So the cache is transparent, but basically it means that if you have something in local, or if you have something that you just got to get, like I did a get entry on this hash just a second ago, you will have it automatically. You won't be doing a get into the DHT.
I see. So all your HDK calls inside single zone function are cached automatically.
Exactly.
Wow.
Yeah.
This is really nice.
Yeah, if you do this commit entry, this meeting room is going to be in the cache for this zone call, but not here because this doesn't know anything about it yet. If this succeeds, then the next layer of the cache will do, yeah, I have committed this. So here you are. But we are getting a little bit deep into the technical weeds of this, but yeah, this is very nice.
So can I just verify I understand? When you make a zone call, let's just say within the scope of this function, right? This zone call, within this call, this request context, so in this particular thread coming in, it has its own, I guess it has its own view space where like any changes you make in there, it's a little world. anything outside of the context of this specific zone call is its own separate, they are in their own separate spaces.
Exactly.
Is that right?
Exactly.
So each
That's
call has
exactly
its
right.
own partition of the world.
That's exactly right. Because what happens if here I commit the entry and then I want to get the latest header? Like from a logical standpoint, I should get this header, but it's not committed yet. So Holochain is taking care of that. It's saying yes, but in this zone call, this is the latest header because you just committed it. But in other functions, that will not be the case yet.
Interesting.
Okay. Yeah. Okay, so I want to show you a couple more things.
This can be really powerful for just, I'm thinking about applications of this, like stuff that you are writing to your own source chain and just wanting to retrieve it without that confusion and going into the DHT, like some of that gets significantly improved, right?
Yeah, yeah, that's one. And the other one is for like, I want it for my mutual credit thing a lot, like so much. Why? Because then you can do things like, okay, I'm committing the entry here and then sending a call remote to you. So I send message. And if you return me the signature, I will commit the attestation or whatever. But if you don't give me anything, I will roll back everything. So this is like, oh, yes.
Yeah.
And I don't know, right now it can make a little bit complex, but maybe worth it to continue. What about the bridge call right now?
Yeah.
Is gonna be the bridge call in the same transaction, or the remote guys that receive cannot be? Most probably it cannot be.
Yeah, I think like this was last time I heard about this was on February, so things may have changed. But on February, Art was saying that it's not going to be the same context. So if you do a bridge to another application, that application is going to have its own context and its own, like you're not going to get atomic between the DNAs. That may have changed. This is the last thing I got.
In this case, event sourcing and reversing the event could make sense. It means if you send a signal of add, if there is any problem and it's supposed to fail the whole transaction, you need to send a signal as a remove. It means you assume, it means an event and a reverse one. It means add, the reverse is delete, update, or update to previous version. It means because they are not on the same transaction to roll back, but you can reverse the event that it happened previously. Did you get my point?
No, sorry.
Look, same transaction, it means I'm doing something, I'm calling you, you also do continue, and then get back to me, I continue. If it is okay, I'm telling you also you commit. Both of us are commit.
Right. Yeah. That's so, totally, yeah.
Yeah, if that, most probably they cannot both on the same transaction because they are two different guys from a different conductor. Maybe event can work. It means this one is still on the transaction, continue here, come here, call this one, continue, come back, oh, roll back. So I want to roll back, but you already finished your job. How I can do, I can send you add record, and after I finish, if I want to roll back, I can send you remove. It means you implemented both, but you reversed your action.
I don't know about that.
It is kind of event sourcing. Yeah, it is the event. So it means anything is committing, but also we have a reverse action. That's it.
Yeah.
Yeah, we have to do that extra, I guess, because it's not done by Holochain for you. So you have to do the compensating. It's like compensating operations. to reverse that, right?
Most probably we need to do it in the app level. Oh, sorry to interrupt you.
No, sorry, but I mean, but then there's no guarantee the reversing operation will succeed to be able to undo what you did before.
Can be another option. Yeah, can be.
Yeah, you could also do things like, okay, I'm bridging to you, and then you are bridging to me just before finishing to be sure that my state has not changed more, you know? So
Ooh.
1 and then 2, and then if that fails, that will fail and that will fail. But we'll see.
We will see. Let's continue. Yeah, it's not a big deal.
Okay, so I want to show you a couple more things interesting, more on the syntax and how things are done now. So this is the new way of defining entries. Just one line. So HTTK entry, ID, visibility, public. And then here you can say other things, but I haven't dig too much into it. So it's like CRUD, I don't know. The important things are here. There are a lot of changes in the name of things. So for example, agent address is now agent public key. Address is segregated by type. So this is a hash of an entry or a hash of the header of a hash of the DNA or whatever. Like you cannot mix those now. To import the functions for the HTTK, you just do HTTK prelude as you were doing in the latest version, and it just brings everything. And then this is the way that you define entry definitions, like you are defining entries in this outer space, but here you are telling, okay, this zone has these entry definitions. And then this is the way in which you do an external call you can invoke from the UI. And here there is a caveat, which is now the parameters, input or output parameters of the functions is much more strict, in the sense that there can only be one parameter. So you cannot do this. This you cannot do. And parameters in and out have to implement this trait, basically. This is kind of a trait, which is telling the Holochain WASM runtime how to serialize and deserialize into and from vector of bytes. So imagine from the UI you're sending a JSON, that JSON gets converted to a vector of bytes, an array of bytes, and that array of bytes at the end gets through the Holochain conductor and at the end gets to your DNA code. And the only way to match that vector of bytes to your structure is to define a struct yourself that implements this trait. And then you can receive or return this type. You know what I mean? You cannot do this, because it wouldn't know how to interpret what's a vector of meeting rooms, because you have not defined this in vector of meeting rooms. But if you wrap it up in this struct, then yeah, it knows what to do. Just a little annoying, but you can live with it.
Actually, it is a design pattern. It is the message pattern. Actually, I'm really love this pattern. Always I'm putting in my architect, because exactly all the returning function or returning any message or anything, return a one type, and if it is complex, you can make it complex. I love this pattern. Just we return one struct. If there is a list, we put inside the struct. If there is any kind, we put. It means one function, one message. And even we can inject error message inside. It means we have a struct with the error message, true or false, something like that. We can make it generic. I love this pattern.
Yeah. I'm glad. Okay.
And where
Yes.
do you define
Sorry?
validations for the Holochain entry?
Right.
I see they are not defined in the entry definition, so where are they?
Right. And I have to say that I have not played with that yet, mainly because it's not fully implemented. So when we execute this, just in a moment, you will see a lot of unimplemented pass-through invalidations. So there is this pull request, yeah, app validation that has to be merged. It's not, yeah, it's not being merged yet, but I can show you examples because it's already defined on the HDK. So, okay, this is the main repository for Holochain. It's private yet, but in Tuesday it will be public. And inside creates test utils was, so there is a place in which you get all these examples, right? Examples for anchors, for, yeah, different HDK things you want. And in here, I can show you very, like, yeah, okay. So
Could you also increase the font size, please?
Sorry.
No worries. Thank you.
Okay, so you have validate. You can go different ways, actually. You have validate, and you don't assume what this entry is about. And then you do validate callback result, which can be valid, can be invalid, and can be dependencies missing. 3 options. So we actually get a lot more control on how our validations are working. And then you can also do things like, oh, let's see if they have done this. Okay. Okay, here is validate link. So if you noticed, I didn't, in my code, I didn't define any links to or from the meeting room, but I did link. So that's how it is, basically. You do not define links, you link. And then that link can be validated running some callbacks, or maybe not. If you don't have callbacks, validation is correct, and that's it. You have to be careful about that, though. So you would validate links like this, validate link, and then more or less the same thing. Let me try to find.
We would have one function for validate links, and in the body we should recognize which link, or how we can connect this validation function with entries, with the entry definitions.
Right. So let me try to find, because I know I'm not so sure about links, but I know that with the entries you can define. They have not done it yet. Okay. Let me try. Otherwise, I'm just going to tell you. Yeah, like this, but okay. So what you will be able to do, I think you are able to do that now, but not exactly to what extent. So you will be able to do this. Function validate and then meeting room. And this is the ID that I put here. Okay, and then this will receive a meeting room. and I can return a validation, what is it? External result, validation, callback result. This you are able to do. I'm not so sure about links because links don't have an ID.
For link does not make sense at all. I also
No.
think so, because if we don't have any definition for a link, with which one we are supposed to connect, totally makes sense. In links, one general function for all of them, and inside we need to put a switch case or something to recognize based on the string. But this one, yeah, good. For the beginning, it is good.
So if we only have a single function for the links, how do we ensure that links would be created between the right entries? So if you want your meeting room to be linked to, let's say, its host, how to make sure that the meeting room doesn't get linked to, I don't know, something else that is not supposed to be linked with it.
Right, so Holochain is assuming that the default is not that. The default is anything can be linked to anything. And then if you want to enforce things, you have to write that.
So you would write this validation in the validate link function, but
Mm-hmm.
other than that, Holochain doesn't make any checks.
Mm-hmm. Mm-hmm.
Mm-hmm. Okay.
I think so. I think that's the case. Okay. Other thing is we can say, I can show you. Not
Sorry,
here.
so this validate link is this Uber. It's like the Uber validate link. Everything goes in there. And if you want to further split out validation for different types of things, then you kind of have to go from this entry central link validation function into whatever other finer grain functions. Is that right?
Exactly right. I'm not finding the call remote. I can just do it here. Okay, so instead of send receive, we have call remote now, which takes the, like, I'm just getting this by memory, but I know I can show you, sorry. So here, capability. Great. We have this. We have call remote instead of send receive, which takes, this is the agent. Well, the agent, you need the agent and the DNA, and I think this is it. You need the zone name, you need the function, you need the capability, and you need the parameters of the function. Okay, and this is, I think, much better because if you remember with send receive, we had to do wrapping, unwrapping. Okay, let's define a struct for the messages I'm going to send you, and then the different types of messages are an enum, and then depending on the type of message, the enum can contain things or not. And with this, I'm not doing any of that. I'm just saying, okay, call this function here. That's it, of this agent, and that's it. And it will automatically check the capabilities for you and so on. So that's call remote. Other things are maybe more minor, which is things like you can now generate timestamps from inside Holochain code. You have more access to information about the zone you're in and things like that. What can you do else?
Just a quick question on the callback, call remote, sorry. Are there any restrictions? Do you know if the DNA that you mentioned has to be within the same bundle? Within the same app, sorry?
I don't think so.
No.
That's
No,
a good
right?
question, but you
It
shouldn't.
just has to be on the
no.
same conductor. I think that's what
Yeah,
Art
yeah,
said in our session. It just has to
yeah,
be on
yeah,
the same
yeah,
conductor.
yeah.
Okay.
That's what it would make sense.
Yeah,
Otherwise,
because
they would.
yeah. Why would you call? Why would you call?
No, you wouldn't be able to call like personas or deep key, and you should be able to call deep key, absolutely.
Yeah.
Deep
So
key.
long as it's on the same conductor.
Yeah, exactly.
Yeah. Cool.
Okay, another thing is that capabilities are much more present now. So, like in the last Holochain version, capabilities were kind of baked at the end, and in this version, it has built in from the get-go. So, actually, in the previous version, capabilities were kind of finished, but not quite. So you could get around without knowing much of them as an app developer. And in this version, you cannot do that. If you are trying to send messages and do capabilities thing, you have to deal with capabilities. And then I haven't played with this yet, but in the Genesis function, which is the function that gets executed when a DNA gets installed, there is a new entry that can go at the beginning of your source chain, which is the joining proof. So you have first the DNA, second the agent ID, third is the joining proof, I think, and fourth is the capability grant for your key. So the joining proof are things like the ticket that in lib we are designing for with all of you basically. Yeah, in other things it can be other things, right? So in the social triangulation it would be vouchers, and when you validate that agent, it gets validated through together with the joining proof. So you have like the I don't know, the enough vouchers or whatever that gets validated as well. You can think also of invite codes and things
Any
like that.
membrane control, right?
Exactly. So now there is a dynamically you can
So
dynamically define that space.
do you know how the mechanics of it, like how does that get assigned to an agent when they join? Like, is it another agent on the DHT that's assigning it to them?
That cannot be the case, I think. I think the only thing that makes sense is that when they install the DNA, they pass the joining proof. Otherwise, it doesn't make sense. Because they have to be able to commit it without even asking the network.
But that would mean like bridging to some other DNA, right?
Or just you don't need to do that because you can send it over from the UI. Like from the UI, you get the ticket from this other DNA and then you send it over here. And you cannot, like, it's a deadlock in a way if you do it otherwise, because if you are going to ask someone in the network for some joining proof, they are going to first ask, okay, are you valid?
Yeah.
And you're going to say, no, I'm just asking you to be valid.
Yeah.
And they're going to say no.
Yeah, that doesn't make sense.
Doesn't work.
So what happened? What happened if this validation is gonna be false, and right now the user is not supposed to create a DNA at all, or he's gonna be create DNA locally, do not propagate? So what is the final decision?
That's a good question. You know what we can do? I don't know the answer to that question, but we could try to ask the code. So the code is much more readable now. Like you cannot compare the two codes. So in this core, there is this workflow, and all the workflows from core are here, basically. So your question is, okay, what is the behavior of the Genesis workflow? So let's see basically here. So right now, there doesn't seem to be, okay. Doesn't seem to be any check other than going to the key and asking if the key is valid, but this may change in the future. So, okay, not that good an answer as I was expecting to get you, Hedayat, but this is what we have, and I don't know more.
Thank you. That's great. I can see that maybe it is the open topic because it's a big topic. What you are going to do, not propagate, but generate for, because when I'm invalid, mostly I'm valid for myself, you know, I'm not valid for the network. It means when I'm invalid, personally, I'm valid, but others are not going to play with me, but I can play with myself. You know, it means it depends how they are going to answer this question. But thank you. That is fantastic. Your process, fantastic.
Yeah. And actually, like, reading this code is quite, yeah, it's quite easy. Like, okay, the call zone workflow is maybe the worst one in that sense, but you can see basically what it's doing. Okay, so it's getting the chain head at the beginning of the call. It's calling the ribosome, so just to call the zone function. It's getting all the things it has to validate after calling the zone function, right? If there has been changes, so it does some checks on that. So you can see like, okay, these and these and these and these, and then it's done. So it validates the entries. This is validating the entries and the links, and it's done. And actually, like, I was able to, okay, so I needed the post commit callback. Okay, I haven't talked to you about that. Let me finish this. I needed that callback, and I was like, okay, I don't know when core is going to be updated and so on. And I asked the guys, and they said, okay, do you want to try it? And in 10 minutes, I was able to put the callback here and just like, okay, call the ribosome and do these checks with the network, and first try it work. And I was like, whoa, okay. So for you guys that are experienced with the code and these kind of things a little bit, it's not difficult to modify. And with Connor, for example, we were able to return the tip of the source chain without the core team actually having implemented it. Hacking, okay, the return in this function has to be this, so okay, let's do this, and it just works. So I recommend you, if you have energy and motivation to it, to just look it over a little bit. We can do that on another session if you want, but it's really interesting and not that hard to grasp. And then I want to talk about the callback grammar. So in the new Holochain, what you can do things like post commit. And what does post commit means? So post commit is a thing that will run after everything that you commit. So you define post commit and you get some hashes that correspond to the entries you have committed, and then you can do whatever you want with it. And this is after the fact that you have committed. So you can think of, okay, after anything has been committed, let's send it over to the indexing node to index. Or before or after the init function has run, after I have joined the network, do these things. Okay, so there is a very rich grammar, and they have been putting the time to for this to be extensible. So adding new callbacks or new things like this is very easy now. So they have to still figure out the complete list of all the hooks that there will be available. but I think this will become really handy for app developers. Like okay, I imagine let's do an application that has an indexing application complementary. Okay, wait, in the previous version, I couldn't use any zones that did not call directly the indexing nodes or things like that, because all the entry definition and everything is in that zone or that mixin. So I have to now hack into the source of that library, whereas now I can say whatever is committed, just send it over, and I'm not worrying about that anymore.
It is zone level. It means any post or commit on each zone, it's gonna be received this one, or it is application level. What's happening?
I think it's zone level, but I would have to confirm.
So if we are going to implement the indexing is supposed to be application or zone. So let's imagine it's gonna be this. It is gonna be a caret or it's gonna be a zone. So if I want to, if I have my own zone library entity, if I post, I would this method is gonna be called. So here I need to send another call to another zone. Just please go for
Right.
indexing. Yeah.
You're right. In that sense, it would be much better for it to be application level. So I don't know. I don't know. And more than that, I think it's not implemented yet, because this is the one thing I did hacking the core. So I know that it's not implemented in core yet. So it's implemented in the HDK. The HDK is the layer from the application that you interact with core, but it's not implemented on core, on the receiving side of that. So I don't know exactly how that's going to be.
So, Guillaume, based on the things we have, it means I recognize the application right now. It's a kind of logic. It means it is. I'm really curious right now to see what the name of application playing role here exactly. It means when we create application, it means like a boundary with a combination of different zone. It means just imagine this scenario. It means any zone supposed to receive a one event and just propagate to one layer upper to the application. You know, it means there's application. I have a 4 zone inside. If I would like to have something in application, I need to grab that event and just propagate to one layer upper, you know? Or we don't have any logic of application at all. It means it is just a microservice. It means generally in your conductor, you have 20 microservices. So, but there is a logic that we are calling this 4 zone, it's kind of application. Which one? Do we have right now a wrapper that we are handling something that say, hey, it is a wrapper, 4 zone application named Leap. I don't see right now the clear logic of application.
I think I get you. And if you are talking about some middle layer at the DNA level in which you could manage zones, receive events from the zones, and do any kinds of management at that level, I think the answer is no. That doesn't exist right now, that's for sure. And I haven't seen anything of that sort to be foreseen in the future.
So, generally, in that case, the logic of application generally we don't have. We just have a DNA and different zone inside. That's it.
Yeah. Well, you could do like a management zone that other ones bridge in. That you could do.
It's a really interesting topic. Okay, maybe we need to continue later. It means, what does it mean, application?
No, but I agree. I think we're going towards very generic microservices. And I think that is also exciting to me.
Yeah.
Because it's not, anyway, I think that is another topic. And I think that's also where neighborhoods comes in, but yeah, that may be another discussion.
Yeah.
I'm gonna have to jump off, guys.
Yeah.
But I'll watch the recording when you share it, Game.
Yeah. Actually, I think we are pretty much done. The only other thing I was going to do is show the test and run them. That's it.
Sure.
So the tests are basically the same, almost exactly the same. This is because Triorama had just been adjusted a little bit for RSM, not fully rewritten. Maybe we'll get that in the future. I don't know exactly. So you do conductor call, Alice, which cell you want to call, which zone, which function, the parameters, and then you do these tests. Same. We are doing some sleeps for things to get propagated because the tests do not wait automatically like they did in the last version. So just to run this, you do first to compile. It's let's see, it should be it's going to take a little bit. So you do this cargo build, which is Rust basically. You do DNA util to get the compile code into this bookings DNA.jc, and then you go and you do npm test, and that just runs it.
So
that's
now
it,
we don't
basically.
have the, sorry, so now we don't have a tool chain for building Holochain applications, and we are directly using Cargo.
Not still. Let's in the future, because this DNA util step, I think they will want to wrap it onto some other thing. And you haven't really seen it because it took some amount of time to get everything boot up and so on. But now, like, these things are incredibly fast. Like, very, very fast. It's the same if you pass it like, I don't know, 100K worth of data, like the call lasts 0.004 seconds, something like that. So it's
nice.
It's like that. And it doesn't get up your CPU 60% like the last version. And it just, it's a pleasure to work with. Yeah. Okay, and I think this is all I have, at least for now. Do you have anything else, or otherwise we can close and see you have been watching everything as well?
That's great, and I hope we do more of these.
Yeah.
So thank you. Let's go back to our normal window.
Okay.
And it's nothing. I think yeah. Wow! Like always, we love you, man. Thank you. We
Thank you very much.
learning from you a lot. Thank you. So I have also suggestion, guys. What do you think if we can maybe together, or we can read it and bring some question? We can review the. Do you remember Art Brock shared the document of RSM, the new version? I was thinking maybe one time we can review this document together. What does it mean? Because it is a fundamental there. Do you think it is good, or I just had a suggestion? Up to you.
I think that's really great. I mean, Gilliam, I mean, even today, I think I'm gonna have to go through what you said and really think about, really absorb that, because right now it's sort of floating there. So yeah, I think thinking about it, and then, like what Hidayah suggested, looking through it, sharing the thoughts, coming together, I think would really help everybody's understanding.
Right.
I would also want to add that we might need to split this into multiple sessions, because I don't know about you, but I start to doze off after an hour, a little bit. So yeah, it would be more productive to have smaller sessions.
Sure. Yeah. No, Hedayat, it's funny you mentioned that. Like that document is what I was working on February. So, yeah, like for me, it would be awesome to share it with you also. Yeah.
We are
And
gonna
Awesome.
read.
Thank
I'm
you.
also,
and I
we
think
are,
you need that. Yeah. No, I think we need
yeah,
that as in Holochain hasn't had a formalization of the protocol and what does it mean to do this action and this action and this action, and that's that document. So I think that's great.
Awesome.
hey guys, about this kind of stuff, we are gonna continue with the Amix group, okay? And please share, Guillaume, please share the link there, and we are gonna just talk about this topic there.
Awesome.
Okay.
Okay.
Awesome. Great. Thank
Guillaume,
you, guys.
Thank you so
Thank
much.
you so
Thank
much.
you.
Yeah.
Bye.
Bye bye,
Thank
guys.
you. Also.
Yeah.
Bye.
Thank you. Have a good day. Have a good night.
Yeah. Have a great Sunday. Bye, guys.
Thanks. Bye.